Hey everyone, welcome back to Pilot Math. We're going to talk about topological spaces. So in your mind, we're trying to simulate the real world. And the first thing we're going to do is we're going to simulate the concept of nearness. We don't have a direction in topological spaces, but we can tell certain things are close or not. And in some cases, we can tell whether they're closer or farther, but not really. So here we go. A topological space is a set X in conjunction with a subset of its power set T. This T will be called a topology when it satisfies the axioms. The axioms are that the empty set and the whole set are in your topology. Arbitrary unions, so any family of elements of T, if you take their union, you end up back in T. Finite intersections, if you take any finite collection of members of T and take their intersection, you end up back in T. And that's it. So basically what you have is something that models what you think of when you think of open sets, if you're familiar with those. Arbitrary unions of open sets make open sets, and finite intersections of open sets make open sets. So we call the members of T open sets. These just kind of tell you if you have a point in your topological space, it's in an open set because it's at least in X, it's at least in the entire space. And you can tell if something's close to it or not by, is it in the open set that this point is the point you're wondering about? Is it actually close? Well, you can look at whether it's in these open sets that contain your point of interest or not. And the complements of open sets are called closed sets. You can actually formulate this entirely in Bizarro land by using closed sets. So that's a topological space. It just gives you this notion of nearness. Anyway, like, comment, subscribe, and I will see you in the next video.